Thank you everyone for joining today. We're gonna give it a couple more minutes for people to fill in. We'll go right at the top of the hour at 2 o'clock today, Eastern time. All right, it is 2 o'clock, top of the hour. Appreciate everyone joining today. We're going to talk about some tips and tricks of some of our water level data loggers and how to deploy them. We have a large line of water level loggers that we've built over the years, so I'm excited to kind of talk about just the different ways to kind of manage and monitor your applications. For those of you that don't know me, my name is Andrew Thompson. I'm a sales manager with HOBO. I've been with HOBO Data Loggers now for 5+ years. A big portion of my time at HOBO has been around water resources, water level being a large part of that. So again, thanks for joining today, and I'm looking forward to talking to you guys about the different options that we have. A little bit about Onset or HOBO. We make the HOBO data logger. So this is a pretty infamous name in the industry. We've been doing this for a long time, over 40 years now. We've been making HOBO data loggers, and we've been doing it right out of Bourne, Massachusetts. So we actually manufacture everything right out of that facility in the US. It's an interesting place to have a production facility, but a great one as well. One unique thing, last year in April, we were actually acquired by a company called Lightcore. Lightcore is a leader in the greenhouse gas monitoring space. And so together, we have over 50 years of experience in environmental monitoring, and a lot of great things to come with this kind of partnership here, with just the different offerings that we have and how they complement some of their product lines, what we're going to do in some applications we're already involved in together, and some more for the future. We are a world leader in data loggers. We have a global network of channel partners and distributors. And we're also, as you know, a manufacturer, we are ISO certified. Some webinar details before we get started. So this webinar is going to run for around 50 minutes. And then at the end, we'll save about 10 minutes for question and answers. If we end early, we'll stick around to answer any questions that come up for an extended period of time. Also, I have on here with me Brett Stebbins. Brett has been in the industry, the data logging industry, for water level monitoring. Specifically, he's out in California in Sacramento, and he's on here to answer any questions that come up in the chat. He'll also save some for the end if we want to talk a little bit more detail about them. So put your answers or put your questions in the chat. He'll respond to you. And also, following this webinar, we will send a recording. So that will be sent out via email following this webinar. For today's agenda, we'll talk a little bit about just the different HOBO water level solutions. Again, we have so many. We've come out with so many over the past couple of years. So we'll go through those different options. Then we'll look at the HOBOware or the HOBO software solutions that go along with those different product styles. And then we'll really get into kind of configuring your loggers, deploying them, how to mount them properly. Again, so many different styles, so many different ways to do it. And then looking at what the software tools offer as far as offloading and kind of visualizing your data. Again, we'll end with a question and answer section. So one of the first things that I like to ask customers when they're looking to do really any type of monitoring is, how do you want to collect your data? And so, HOBO has made a couple different product lines really based around the way that you want to collect data, whether it's, deploying something in the field, coming back and collecting it and seeing those long-term trends, or it's real-time communication that's pushing data up to the cloud. So between these three options, we really started with optical communication. You see it over here on the left. Those utilize a desktop software, whether it's your laptop or desktop. We have a HOBOware Pro software that will utilize kind of a USB offload, whether it direct connect with the USB cable, or it uses some of our optical interface to hook up via USB as well. That's a standalone option. You leave them in the field, you come back, you collect the data over a period of time and view that data. Recently, over the years, we've come out with a bunch of different Bluetooth options, which really kind of streamlines that standalone data logger process, where you are still leaving them out there, you're leaving them in the field, you do have to come back to the site to collect them, but it's designed to really be more of a wireless offload and utilize a free Bluetooth app right on your phone, tablet, or laptop. To streamline that process of configuring, deploying, and offloading your data. So that's been a great addition. We've come out with a lot of products that have that Bluetooth built into them. Lastly, the cellular-based solutions, which are becoming more of a need with how many different sites people are trying to manage and all the things going on in the world, that we need real-time access or alarms and alerts for our data. We also have cellular-based solutions that will push data right to our cloud-based software so that you can get that real-time access, set up text message and email alerts, and all the great things that come along with real-time data. So I'll start by talking about some of the oldest ones in our line, which is the optical USB pressure transducers. So we have two different options in our line. We have the U20L series loggers, and then we have the U20 on the right, which comes in stainless and titanium options. Both of these are standalone pressure transducers that would be deployed and give you an absolute pressure reading. We utilize a non-vented style pressure transducer, and that's really for being maintenance free and kind of hassle free deployment. You can utilize another one of these loggers, these same U20Ls or U20s, for your barometric pressure reading. So that baro pressure or that baro logger is actually going to compensate for these ones. Even if you have multiple of them in an area, you can use that additional barometric pressure unit to compensate and give you water level data. But what's great about these pressure transducers is very easy to deploy. They're very versatile, where you can put them on different applications. You can, hide them well and avoid vandalism or things like that. So they're very versatile in where you can kind of deploy them. Both of these loggers use our optical data shuttle or base station, which I'll talk about in the next slide. And those work or hook up with our HOBOware Pro software. The software has a ton of great features, and I'll talk about them specifically, but they will do some of that post correction for you in Data Assistant to provide actual water level readings. These are data loggers. They're meant to be left out in the field. They're rugged and reliable, and these loggers will actually allow you to log anywhere from 1 second to 18 hours, and you can leave them there. If you're doing 5-minute, 15-minute intervals, you can leave them there for months at a time. There's very little drift with these pressure sensors. It's a ceramic sensor, so it's very durable. So they'll last, and you can leave them out for months and collect that data later. As you can see, the U20L series, so this came out after the U20, as really one of the most economical, if not the most economical solutions on the market. This pressure transducer is only $385. It's a polypropylene housing, so it's good for both fresh and salt water, and it comes in 3 different pressure ranges. You have 13-foot, 30-foot, and 100-foot rated transducers. The U20s, which have been around for an extended period of time, these are kind of the tried and true. These are a little bit thinner of a unit, a little bit better accuracy and response time, and they also come with a 3-point NIST traceable calibration certificate, and they also have a greater depth option at 250 feet. Again, both great solutions for long-term monitoring. This is so I talked about the optical base station and shuttle that is utilized for those pressure transducers. We have two solutions, the base station and the shuttle. The base station is almost pretty much a USB cable that connects up with an optical interface to the logger. So one end, you can see right here, there's a little coupler. It plugs into the logger. The other end has a USB cable coming from it. That will plug into your computer so that you can configure, deploy, and do everything right through that HOBOware software. The shuttle actually has some extended capabilities where same thing, it still uses a coupler in that optical interface. It also has a USB cable that can be plugged into it. But what's great about this shuttle is you don't have to bring your equipment to the field or bring the loggers back to the office. You can actually just bring this waterproof shuttle out there. It's almost like a memory stick, and you can offload up to 63 full memory loggers while you're in the field. The other great option about the shuttle is that it has, it's waterproof up to 20 meters. So we have a lot of deployments where customers don't want to remove the equipment because, they don't want to disturb the environment, and they'll actually dive down and offload right from this waterproof shuttle and then offload, right from their office later down the line. So again, it has internal memory. That's all you have to bring out to the field, and then you can bring it back and do your data offload after. So now we have a couple different solutions on the Bluetooth side of things. We just came out with a new one this past year in December, which is the MX20L series logger. So very similar to the U20L, but a Bluetooth version of that. So this is a fully submersible Bluetooth pressure transducer that can be utilized the same way as the other ones. You can use an additional one for barometric pressure, but what's great about it is it has that Bluetooth built in. So now you're going to be able to utilize that free HOBO Connect app to configure, deploy, and offload your data while you're on site. Another great aspect of being able to do that on site is you can troubleshoot while you're on site. So when you pull that pressure transducer out of the well, you're looking at your graph, you're looking at your reference level. Does this need to be recalibrated? I'm adding my barometric pressure right there. I'm creating a compensated water level file right there on the site so that I'm done and don't have to bring it back to the office. What's also good about the MX20L series and some of the things that we've enhanced it with is up to a 10-year battery life, and then also up to 400,000 measurements for memory, which is much greater than the U20 series loggers. So we've increased memory and increased battery life. I know there's a lot of extended deployments beyond 5 years, so this is a great source for that. Still polypropylene housing, so still good for fresh and salt water. It literally is the same as the U20L, just with Bluetooth capability and some of those extended features. Along with the U20L being one of the most economical pressure transducers on the market, this is only $399. And what's great about this one is there's no software. It's a free app. There's no shuttle that you have to pay for. This is actually even more economical depending on the deployment. Again, one of the most economical loggers on the market. We move over into the MX2001 series logger. So this is a Bluetooth logger that is more of an all-in-one solution. So it's actually a direct read style logger, which your Bluetooth head or the data logger itself that has your Bluetooth, it has your battery, it has the memory built into it, that would be situated in an area that does not flood or can't, it can't be flooded ultimately because this unit has barometric pressure built into it. And with that Bluetooth built into it, it's true kind of wireless offload. That's one thing that HOBO does unique compared to other options on the market is that we build Bluetooth into these loggers so that it is true wireless offload. You don't need to attach a dongle to it, for example. With that barometric pressure, it's giving you water level data right out the gate. You're punching in your reference level from the very beginning, and you're off and running from there. With the Bluetooth offload, you can get typically up to 100 feet, line of sight from that logger. If it's buried in a well, you might have to get a little bit closer, but ultimately this is great for areas that are hard to reach and hard to get to. Also, if you have a significant amount of wells or a significant amount of transducers out there or setups doing water level, it's quick and easy. It's wireless offload. It pops up when you get within range, you offload and you're on your way. With it being a direct read style, you can get any custom lengths up to 500 meters for that logger. So you can do some real deep groundwater wells, for example. Then we recently, last year, beginning of the year, we came out with the MX800, which is one of the first kind of multi-parameter data loggers that is fully modular and interchangeable. And so one of the options for this MX800 is a Bluetooth water, or it's all Bluetooth, but it's a water level and CT solution. So these are more commonly known as a CTD on the market. And what's good about the MX800, as I mentioned, everything's interchangeable and modular. So not only can you do a fully submersible version like this MX20L, but you can also do a direct read style version very similar to the MX2001 and get, true wireless offload without having to remove anything from the water. So again, direct read and submersible options, that same wireless offload capability. And what's unique about the MX800 is it really is for both water level and quality data. So not only can you do CTD, but you can actually add a 2-pin adapter to it and add a dissolved oxygen sensor to that logger as well. And there's more sensors to come with the MX800 that you can continue to add to that platform. So now we'll switch gears to our cellular-based solution. So the RX2104 is our single kind of cellular-based water and climate solution. I mean, ultimately, this station was originally a climate station. It has these 5 inputs right here for any of our plug-and-play climate or soil sensors. One that's common with water level is rainfall. We love to see, a bar graph with an overlapping, water level line graph over it. Of your rainfall data, so you can kind of see how the hydrology is being impacted by those rainfall events. But everything that we've done with this logger, it's meant to last, it's compact, it's easy to deploy, and it's all plug and play. So you have the ability to put in any of those climate or soil sensors, plug them right into your station, and run it right with a water level sensor. So when you are doing water level, or you build this station for water level and not just climate, you can actually, the barometric pressure is built right into the unit. So that way it's giving you actual water level data, and you're not having to constantly take reference levels and punch them in to post-process your data. The station comes with a, again, compact design with a built-in solar panel. That solar panel utilizes these rechargeable battery pack that will last 5+ years, and it's user replaceable. Once it's gone, or it's met its life, in which you could be able to tell right through the cloud software, you can replace it with a $45 replacement battery pack. The station also has a digital display, so it's easy to kind of deploy in the field. You can troubleshoot right there. There's only a couple buttons. Everything is really push button ready. It comes with a multi-carrier SIM installed, so you don't even have to worry about the cellular plans or the cloud-based service. It comes with a multi-carrier SIM installed. We have plans as low as $99 per year for the station, and that comes with all the features of our cloud-based software. When you pay that $99, it's really for the SIM card and the data storage. Our cloud software has no cost associated with it. So there's no limitations. When you buy that station, you have all the capabilities that the cloud software offers, and anyone can kind of create an account and join these systems that you want to, of course. Also with the RX2104, I'll just mention, along with calculating water level and giving you that real time, it has the ability to do additional flow calculations as well. So if you have a flume or a wear, or maybe you've built a stage discharge table, this will give you a CFS reading or a calculated flow reading so that you don't have to post-process that data. Lastly, I want to talk about our HOBOnet water level system. So this is part of our real-time water level line. And really, this is a way to scale your site with multiple measurements and do so affordably. The big driver of this HOBOnet wireless system that we have, and it's beyond just water level, but it utilizes radio communication to connect between monitoring points, finding its way back to a main cellular hub. Again, the big draw, it's affordable. You don't have to buy a cellular station for each individual monitoring point, and you don't have to pay an annual cell fee for each individual monitoring point. So this radio mesh network, that you can really scale from, will allow you to connect up to 50 wireless sensors. That could be 50 water level sensors. It could be a whole range of different sensor options that we have, like climate parameters, rainfall, temperature. We have soil moisture sensors, multi-depth ones that do EC, temp, and moisture. You could also do third-party sensors or water quality sensors. You can tie this all in to create this large mesh network of sensors and filter that back to one main hub so that you can really drive that cost down and scale your site affordably. Everything that we do, and you'll notice, is meant to be user friendly and deployed on your own. And so with these moats, these are the wireless moats here. They're even more compact. They still have a built-in solar panel, 2 rechargeable AA batteries, but these compact moats right here, it's as simple as hooking up kind of a Bluetooth speaker. You press the button on the station, you hold the button down on these moats, they tie for life, and then you put them out there and they find their best way back. It's a self-healing, self-forming kind of mesh network, and it will adjust over time. If your site adjusts over time, maybe trees grow in or brush grows in, it might find another path back in the future. So now we've talked about the different solutions for water level. We're going to get into now the software piece of it before we really get into kind of deployment tips, how to deploy these different loggers, how to configure them, specific to what they are and how they do them. But we'll talk about the software first. So the HOBOware Pro, this works with those optical U20, U20L loggers. I mentioned they are compatible with the data shuttle and the base station. HOBOware is a software that's been around for a long time. A lot of great capabilities in there. It's easy to kind of configure configure and offload really your equipment, but it also gives you the ability to do presentation quality graphs. Everything can be exported, whether it's CSV or Excel. It can be exported right from the software platform. And then we, along with everything in all of our software, we try to do that post-processing for you. So there's a lot of data assistance built into HOBOware Pro so that we can give you actual water level data or compensated water level data. The HOBO Connect app is what we use for our Bluetooth loggers. And again, this is a free app that can be used on, an iPhone or an Android. It can be used on a tablet. It can even be used on a Windows computer. And with Bluetooth technology, you could be in a remote site. You do not need cellular connection with Bluetooth technology. So it's really just that connection between your phone and the device and being within range of it. We use Bluetooth 5.0 technology. Everything can be customized, all your logger settings. You can even, what's unique about the Bluetooth is we have some unique logging settings like burst mode where you want to log more rapidly during a period of time that matters, or to start logging you want to log quicker than after the first couple days. So we have unique logging, different logging capabilities with the Bluetooth loggers, and again, everything's done right through the app itself or the software. You can calibrate your equipment. We have the built-in data assistant for actual water level data to do all that post correction. And then again, you can export everything, whether it's CSV, Excel, HOBO file. You can even export a picture of the graph. In HOBO Connect, when you pull it up and you offload, it gives you a nice graph. You can select what parameters you want to see, and then you can even export it as a PNG. So lastly, we have our cloud-based software, which is Lightcore Cloud, and we've made a lot of improvements to this software over the last year now, and a lot of great features to come, really. We know that kind of real time is the future, and so we're investing a lot in the Lightcore Cloud software. Let me get this out of the way. So with cloud or with the real-time stations, you're going to get real-time data, and so we have you can build customized dashboards right in our software. You can kind of see a little visual in this picture right here, line graphs, gauges, bar charts, all these different widgets to build a dashboard that makes sense for you, but also makes sense to view for others. So we have an option with the dashboards to do a public URL. Let's just say you have a client or you want the public to be able to see or access information without logging into your account. You can share a dashboard and create one specifically for them to access. It's somewhat interactive. They can, change the dates of when they want to see data from. They can zoom in on different sections of the graph. So it keeps them informed without having access to the actual site itself. You can create dashboards for yourself. You can create dashboards specifically for the public. There's really no limit to how many you can make. We also have a Google Maps feature. So this is great when you have large networks of stations or those wireless HoboNet, networks. Those are, you can put them right on the Google Map. You'll see how they're kind of filtering back and creating that mesh network back to the hub. And when you click on any of those sensors, it will actually show you what the most recent readings were. It will give you insight into, if you're getting a bird's eye view of, is a station down, is something not performing, it'll kind of mark it in red and alarm you of that. Real time also brings alerts, which are crucial. Showing up to a site and finding missed data can be detrimental, obviously, for a program or, if you're doing something for compliance purposes. So having alerts being sent to you via text message and email, and there, again, no cost associated with that, is something that's built into our system and a huge value. And so we have both system and sensor alarms. So your system alarms are, if a station goes down or battery is getting low, it misses a cell connection, it'll send a text message or email to whoever you want. There's really no limit to it. It'll push that right at the moment it happens. Your sensor alarms are more geared towards the parameters. So if you're talking about water level, high water levels, low water levels, when that's triggered, it sends a text message to so-and-so. This is, we do this a lot for dam safety or stormwater management. These alerts are very crucial and helpful. Everything can be exported via Excel. The real-time software streamlines that export process even more so. You can do a bunch at one time. You can even create automatic exports, scheduled ones. So, I want to see the last 30 days of data. I want it sent to me every month. You can set that up as an Excel file. It sends it to your email. You could also dump that into an FTP as well. And then we have integration into other software platforms. So with all the different software solutions out there on the market, sometimes there's ones that are more applicable to exactly what your application is. And so you can just take our data, use the API, and dump that right into your software platform. There's no extra cost associated with that. And then lastly, just one of the biggest changes and why we moved over to this Lightcore Cloud platform was to bring more of an enterprise-based platform to our users, so that people that are managing multiple sites or want multiple users involved in a site, you can now do that. So before, you used to log into your account, you'd have to share those credentials with someone if you wanted them to log into the account and manage things. Now it's all user logins. So anyone can create a login. It's a free software, and you can be invited as a device admin, a device viewer, an account owner. You can be invited to these different organizations so that you can kind of flip through them, see the different sites, and access that data, or provided levels of access for that data to different users. So now we'll get in, well, actually, let's talk about configuring the data loggers, because this is pretty standard amongst all of these solutions. So when you're configuring your loggers, what are the necessary steps? You're going to probably name your logger. If you're using a separate barometric pressure source, you're probably going to designate it and label it accordingly. That way, when you're coming back with 50 loggers on your shuttle, you know which one's been used for barometric pressure, and you can utilize that for the compensation assistant. Then you're going to select your logging interval. So these loggers, they'll log anywhere from 1 second to 18 hours and some different logging intervals. With water level, 15 minutes is pretty common, 30 minutes. Sometimes people only need, every half a day or a day. But you'll select your logging interval. It will tell you how long you can kind of log for. You can see right here, one of the Bluetooth ones. If you're logging at 5-minute intervals, it's going to give you 4.7 years of data. So plenty of memory on them. And then you have the ability to actually wrap or stop when full. So when you're doing maybe pumping tests and you're actually logging at a significant rate in the seconds, for example, you have the ability to stop it when that test is over, or when the memory's filled, or wrap when the memory gets filled and right over the oldest data. You also have start logging options. So this is, when you're configuring back at the office, or even when you're on site, if you want everything to kind of all of your loggers to kick off at the same time, you have the ability to start when you save or save it down, start on the top of the hour, start at a future time and date, and you would actually just select that. So that's all kind of built into the system. With your cellular base system, that's more, kind of when you press go. That's on you, just because you're doing it remotely. When it comes to Bluetooth loggers, it does also have some specific features like Bluetooth always on or Bluetooth on with button push, things like that, so that you could preserve battery life. And that capability is built right into the configuration as well. And then with cloud, or the cloud software, along with logging, you also are getting real-time data, so you have to select your upload time as well. So you could log every 5 minutes, push it to the cloud every 10. You could log every hour and push it to the cloud once a day. So all of that can be done right through the cloud software. So now we'll jump into really mounting, deploying, and then I really want to talk about reference levels as well, because it's something that comes up very often. But I've broken it up. The next few slides are going to be with the optical pressure transducers. Then we'll do Bluetooth, and then we'll do real time, and we'll kind of talk about all these different, all these different things within that. So when you're doing pressure transducers, there's a number of ways to mount them, mostly because they are so versatile. So you have some options here. Over on the left, you're actually looking at, a groundwater well or a stilling well. And what's great about this setup is you have your pressure transducer, right? It's suspended from the top of a well cap. You have your pressure transducer, and then you can also mount your barometric pressure logger right inside the well where it's not going to be submerged. The benefit of that is it's protected, and these loggers are temperature compensated. So you don't want to leave a barometric pressure logger just sitting outside in the open. The temperature fluctuations will be too much, especially with solar radiation impact. So you want to protect that. So you can either put it in a separate housing, put it in a tree, or you can mount it at the top of your well and protect it inside there. Here's a stream site that's using a post mount. Maybe you can use a mast or a T-post, drive something into the stream bed, and then you can mount that logger right to that post. You could use a protective housing for it, which is good. We sell, and I have a slide on that. One thing that you want to make sure with pressure transducers, or really anything for water level, they can't move up or down. If they're moving up or down, it's going to change what the readings are. So we want to make sure that they are suspended in place and in a spot that they're not going to slip. Here's an option down here. You can attach it to a rock or even a concrete block that has some perforated pipe or slotted pipe to protect the logger itself, but this keeps it stable, keeps it in place. If you're talking fast flowing streams, I know some customers that have epoxied them to the bedrock, for example. There's a lot of different options. It really comes down to what's your environment and what's going to stay in place. Here's some more real world examples. So you see some stilling wells built over here on the left up against a dock. So you just have a couple loggers kind of built or deployed right in there. They actually just used a bolt to kind of suspend their line from. In some cases, like groundwater wells, obviously you'd want to cap that off. Here is another, stilling well that's been built. They mounted it right to the rock with a bracket, and they have their staff gauge right alongside it so that they can, cross-reference or double-check or utilize for even their reference levels against the pressure transducer. And then another one here with one of our protective housings, the pressure transducers in there. It's looks like hose clamps right up against a pipe that is connected to the rock as well. So with these pressure transducers, and what's more unique about them is the big advantage is they're less visible. And there's reduced vandalism because of that, but also if you have a recreational area that has boat traffic, it's below the surface, it's in an area that it won't get hit. There's nothing sticking up out of the water. When you are deploying these and hiding them, got to make sure you can also find them. So you can use GPS markers, landmarks, or take pictures of the area so that you know where you deployed this equipment. Same picture as the last one, but if you're deploying them in an area like this, maybe pile rocks around it to keep that area sturdy and stable. And then for groundwater wells, just because these are a little bit more unique with how, or the equipment that you want to use for it, but when you're looking at a groundwater well, typically you're using slotted pipe below the surface. And so you'd have your slotted pipe, and then typically you switch over to standard Schedule 40 PVC above ground surface. give it a bentonite seal so that nothing kind of flows into that well and gives you artificial data. But with these groundwater wells, same thing. You would suspend from the top of the well casing. You'd use some sort of cable here. With the pressure transducer and with groundwater wells, you do want to make sure that the logger's not sitting right on the bottom, just because if silt or sand kind of builds up in there, it can cover the pressure sensor. At the end of the day, you don't need to put the pressure sensor anywhere below what you don't need to measure. So if you only care about water levels that are within 12 inches of the surface, then you put the pressure transducer just below that. You can also drop it to the bottom of the well if the well is actually going to draw down that much, but the pressure transducer is going to read what's above it, and so you don't need to put it anywhere beyond where it needs to be. Also, a note about when you are doing shallow groundwater wells, I do see a lot of perforated pipe or slotted pipe, even with some fabric around it too. There's well sock that you can put around that pipe just to even keep more silt out of it. So here's some equipment that you can use for deploying these pressure transducers. So number one is our locking well cap. So this is one that we sell for 2-inch pipe. What's nice about this is, number one, it locks. Number two, it has a nice removable disc in there so that you don't drop anything in the well. I've seen that happen before, and going fishing is not great. So you have a nice removable disc right there that will not drop in, and you can suspend your cable right from that. You saw a couple deployments that are utilizing a protective housing. This is good for our pressure transducers. You can mount it right to a stake or a T-post and put it right in there. And then we also carry stainless cable and crimps. That way, if you're doing a groundwater deployment, you can suspend it right from this well cap or another well cap utilizing this cable too. Other equipment that would be needed: T-posts are very common, U-post, mast, and then 2-inch PVC pipe is good to kind of run your pressure transducer. So if you're doing like a stream deployment, or you're trenching out an area to kind of run some PVC pipe to get your transducer into a lake, 2-inch PVC pipe is very common. Slotted, obviously, for the area that you want to make sure is vented, and then standard for anything above ground if you're doing groundwater wells. Here's some tools that are not necessary, but good to have on hand, especially when you're deploying some of this equipment. One of them that comes in handy, especially if you're doing a bunch of U-posts or T-posts, is a post driver. You can see that right over here. Also, a small Phillips head screwdriver. That's good for our well caps and then some of our other equipment. You want, some crimping pliers if you're using those cable crimps. Cordless drill is always great to have with various bits. Some snips. That's good for a stainless steel cable. If you need a cut, if you're cutting to fit on site, and then also for any zip ties that you have, just so that clean it up, make it look nice before you leave the site. Tape measure is almost necessary in many cases, not only to get your reference levels, but also if you're working with a dry area, which I'll talk about reference measurements. If you're working with a dry well or a dry area, your tape measure can be used to measure the length of your cable and where the transducer is sitting inside your well, for example. So tape measure is great to have on hand. If you're doing large groundwater wells, or a water level meter is necessary to get a reference measurement. Maybe you're doing an aquifer well and you're dropping a meter down, 50, 100 feet, even more. A water level meter is handy so that you can calibrate our equipment or enter a reference measurement. Rubber mallet is good for well cap install on that 2-inch pipe. So now to talk about reference levels, and I have a couple slides on this pertaining to each individual unit, but one of the things that always comes up is the reference level, and it's talked about a lot because I think once you get the concept, it makes sense. But it's a little bit different when you're in the beginning stages. So with the U20 and the U20L series loggers, typically you're taking a field measurement or a reference measurement, and then you're using that measurement to post-process and create water level data after the fact when you come back and offload it on the software and run the compensation assistant. And so your reference level, it had most think it has something to do with your transducer and where it's positioned. It can, but in most cases, it's just a reference level in relation to what you want to reference. And so that can be elevation, It can be ground surface. You can call ground surface 0. It could be the top of a bridge. There, you're really referencing a point that you want to, that the data makes sense to you. And so when you put your transducer, for example, if you put it in a well and you put your transducer 100 feet in the water, and it's only the water level is currently only 20 feet from ground surface, your reference point can be -20. It doesn't matter where your transducer is. It's a starting point for you. And then what happens with the pressure transducers is they're non-vented style, so they're looking for differential pressure, and they will adjust that water level after you provided a starting point or a given point. The only time you want to know where your sensor is located or measure that out is when you're working with like a dry well or a dry location, because it's only going to measure when that transducer has water above it. So if you're in a groundwater well, it's a shallow one, it's, your transducer is 2 feet below ground surface and it's dry. If you want ground to be 0, your starting point would be -2. And as that starts to see water, or as that pressure transducer starts to see water, it will start from -2 and work its way towards 0. And you can use that kind of, that style or that reference in any case. If you're working with a stream that's dry and you put it at the bottom of the stream, you can call that 0 and it'd be a positive number as it starts to take on water. When you do install these pressure transducers, you want to allow them time to equilibrate. And so they are temperature compensated. So when you drop them in the water, you want to give them 10 to 15 minutes, let them get to temp, then take your reference measurement and write it down. You can use a tape measure for that, or you can use a water level meter to get those reference measurements, and then write that in a field book, time and date that you took it, because you're going to use that measurement later down the line. So you want to make sure you have that on hand when it comes time to run the post process. And then again, we have the barometric pressure compensation assistant built right into the software so that you can add your reference measurement. You select the closest time that logger was taking an interval to that measurement, and then you'll get your water level data based on that. Also with the U20 and U20L series, it doesn't matter really if you take the reference measurement from the beginning or the end, it's going to correct forward or backwards. So I always suggest taking a measurement at the beginning and a measurement at the end. Right when you come back to the site, drop your water level meter in before you ever remove your transducer, get a reading, because if something goes wrong and your data doesn't look right, and it could be because of your reference measurement, now you have two to kind of double check it with and troubleshoot. So with the Bluetooth loggers, when you're deploying these, a little bit different because they're direct read style. I'll get more into like kind of groundwater wells where this is applicable, but you can also do them for streams and other applications as well. But you have your Bluetooth logger up here. This unit cannot be submerged, so we utilize a direct read cable to get a pressure sensor in the area that it's going to be submerged, or where you need to get it to its lowest point. It's custom cable to fit your application, and again, you really only need to drop that pressure sensor as low as you want to measure that water. It doesn't matter if it's a 300-foot groundwater well. If you only care about the top 50 feet, you don't need to buy a pressure transducer that's rated for 250 feet. You just drop it to the point where it's going to fall below it. You can utilize our well cap. That's a great option for the MX2001 and MX800. The MX800 actually uses the well cap 02, but this is a great way to kind of suspend your logger in 2-inch well pipe and do so efficiently. I'll talk about these loggers and when you're in some more challenging environments, I think in the next slide. So with barometric built in, cannot be flooded, and it has to be well vented. If you were in an area that was going to be prone to flooding, but you still want to utilize the capabilities of wireless Bluetooth offload, you can actually use our submersible MX801 with a direct read cable so that you can offload the data, stream side, or, if you're in a hard to reach area within 100 feet, you can offload, and still if it gets flooded, it's not a problem. So here's the MX2001 and just some tips on really mostly the MX2001 and specific to really challenging high humidity environments. One of the things, the logger comes with this black grommet, And this grommet is designed to wrap around the logger and separate the barometric pressure sensor from the bottom of the well. Because what will happen is there'll be evaporation that comes up from the well, it collects on the top part of the cap and kind of gives that a saturated environment that can kind of seep into the logger. So using that grommet is a great you always want to use it, really, unless you're in wells that aren't 2 inches. You can design something similar, but you want to make sure that it's a well vented area, cross ventilation up by the baro sensor, and that you're kind of avoiding any evaporation coming from the bottom of the well. If you have a groundwater well and you have a separate casing over that well, you want to make sure that that's vented as well. Here's some more real world deployments for the MX 2001 and 800. So you have a MX 801, so the fully submersible version with a CTD right here. Nice housing that we have for it, and then it's hose clamped to a cinder block. Here's a stream site. So they have the MX 2001 up here, cabled down with some 2-inch pipe. Their pressure transducers right here, and they're waiting for water to kind of collect in that area. But they don't have to, they can really get bridge side and kind of offload from here. They just needed to get the MX 2001 out of an area that could be prone to flooding. And then here's the MX 802. So not the submersible version, but the one with barometric pressure built in. And this has a CTD sensor and utilizing a direct read cable for whatever size you need. And then a well cap 02 to suspend it in place. So with your reference measurements with the MX 2001 and MX 802, we can kind of skim through this now because it's a similar process. But ultimately, HOBO Connect allows you to do that in the very beginning. So you don't need to go out, take your field measurement, write it down, and post-process later. You actually, after you configure your logger right in the beginning, you're going to run or you're going to hit the water level calibration tool and enter your reference measurement right there. That way you're constantly getting corrected water level data. And when you walk up to your well and it pops up on your app, you can actually see, what that reading is live and export it that way. What's good about the Bluetooth loggers too is it's a constant stream of data. So until you actually stop the logger and reconfigure it, you don't have to merge files. It's a constant stream of data, and you don't have to recalibrate or enter a new reference level measurement in unless you want to. Same thing here. You drop the transducer in. You want to give it time to equilibrate just for temperature purposes, and then you run your water level assistant and enter your reference measurement in. The reference level is the same way. Doesn't necessarily matter where the transducer is. It matters where your water is today at this moment in time, and that's your starting point. So now we'll change gears to the cellular base station. So this is going to give you a great idea of just how compact this water level and climate station is. We have some good real world examples here. This is a great setup. Groundwater well, it's doing water level data. Because it has a pressure transducer and was built for water level, it has barometric pressure built into it. Nice solar panel right there for the rechargeable batteries. And it also has a rain gauge attached to it. Common one for many of these applications. You got a just water level station, so an RX2104 for water level with lake management. And what they've done is they've trenched over to the lake some PVC pipe and ran that cable back to the earthen dam where they're kind of mounting this equipment. A nice unique one is there's an RX station here. This one's not only doing water level, but it's doing rainfall, it's doing surface temp. There's a number of different things that this RX station is doing. They've utilized a external solar panel as well for this one, just to make sure it's got enough power. They do really well with the solar panels that they have kind of built into them. It's very low power, low data type equipment. Here's some other RX2104 stations. Oh, wow, I'm not doing great on time. All right, I'll move along here. So the RX2104 station, we have, this is a groundwater well. What's great about this one is it's also doing, there's a little pulse mode. So it's doing pulse input right in from this flow meter. So you can kind of see those drawdown and recharge events. We have a RX2104 here that's actually giving you a built-in flow calculation. I talked about, having a flume or a wear or a stage discharge table. This one's going to give you not only stage data and temperature, but it's going to give you flow as well. And then just a RX2104 on a dam on this side. with HoboNet, so the wireless setups, those wireless moats that we have, even more compact, small solar panel, AA rechargeable batteries that are replaceable. These, utilizing radio communication, you want to have them at least 6 feet off the ground. So you'd use some sort of, T-post and pipe to kind of mount this moat that has the radio built in. It also has barometric pressure for water level data, and then you'd cable that right into your well casing. You can see the well cap here. This is our well cap 02. And this is good for kind of suspending cable in place, and also has that well disc. It's also a locking cap as well. Here's some real world deployment. So you got your moat. This is a more rugged environment, so they use some 2-inch PVC pipe to mount it. I think it's supported by a pretty hefty U-post as well. And then they have some conduit to run the cable with some hose clamps around it. This is a very standard deployment for like a wetland. They have, a U-post that has some 1-inch PVC pipe, and the moat mounted to the top, and that's cabled into the well cap as well. I will say, I do believe I'm going to end up going over, but we'll still save some time for questions for whoever wants to stick around. Mounting equipment for the RX2100 in the HoboNet system. So here's some things that I would highly suggest. When it comes to those setups I just showed you, a U-post or a T-post for kind of stabilizing the structure that is going to hold the station or the mount or the moat. And that could be a PVC one. If you are going to do, when it comes to the moats, they're very small and lightweight. You can use 1-inch PVC. But when it comes to the station, you'd want to at least use 2-inch PVC pipe. And you'd also, on those stations, probably want to use at least 2 heavy-duty T-posts to kind of secure your station, especially when you're building a large wireless network of sensors. Everything's going to that one hub. You want to make sure it's protected in a sturdy structure. You could also use, we sell, masts or tripods. You could punch a 9-foot mast into the ground to mount this. You could use a tripod. So we sell those as well as an option, and a great option. You have some split conduit here. This is great to hide and protect cable. We go split just because it allows you to, both ends of our sensors are 1 inch. And so you can use some, split conduit so you can route the cable in and not have to use some larger, 1 1.25 or greater conduit. So this is good for cable protection and cable management. Then you got your hose clamps just to kind of mount the PVC and T-post together. And then you also have some zip ties, which are just always common. UV ones, to be exact, just because the other ones will give on you. Here's some tools that are necessary for some of these RX2100 and HoboNet deployments. You got a post driver for those U-posts. Small Phillips head is good for the moat and the well cap. A cordless drill for your moat brackets to screw those in place, and also some hose clamps, various bits for that cordless drill. Snips for your zip ties again. Tape measure to, it's handy for water level measurements or to measure your length of cable. Water level meter if you're doing groundwater wells and you want to need a reference measurement, and then a rubber mallet again for that well cap install. So the when you're doing a reference measurement for the RX2100 in the HoboNet system, very similar to the Bluetooth. You have barometric pressure built into it already, so you're really getting your reference measurement and you're putting it in at the time of deployment. And so our Lightcore Cloud software will allow you to punch in that moment in time when you took your reference measurement, what it was, and from there it is corrected water level data, pushing right to the cloud. And again, unless you need to recalibrate or set a new reference measurement, it's an ongoing stream of data and not required. So down to the last couple slides here, we're talking about exports or data exports and some of the visualization tools that are built into the software. So we have HoboWare, the desktop software that allows you to export everything via Excel or CSV. With these non-vented style setups, whether it's transducers or the all-in-one solutions, you're going to get several measurements provided that you can choose to export or not. You're going to get absolute pressure, you're going to get temperature, you're going to get barometric pressure, you're going to get differential between barometric and absolute. You're going to get differential pressure, and then you're also going to get water level. And so you can choose to export any of those measurements that you want through the HOBOware software. HOBOware also allows you to kind of view your graph right there. Cut it, make certain, zoom in on different sections of your graph and export it as you want. You also have the ability to merge data files. So if you have, if you're going out there quarterly and you really need a year's worth of data, you can merge all those same well files for every quarter into one graph and then export it that way. HOBO Connect, very similar capabilities where you can export. It allows Excel, CSV. Also, if you want a PNG of the graph itself that's provided there. Again, non-vented water level setup. So you have all these parameters that you have the option for. You can select or deselect them. HOBO Connect allows you to also visualize your data. But one thing that it allows is visualizing your data while you're on site, standing there connected to the logger wirelessly. You'll see that, the most recent readings, but you can also click on it, offload, and see the graph as well. Bluetooth loggers, you don't need to merge data files because it's an ongoing stream of data until you stop it or reconfigure. And then the Lightcore Cloud, this is even more convenient where you can still export same way. You can do automatic exports where, every month it's pushing you data of the last 30 days. You could push data to an FTP. You can integrate all that data right into with our API, right into a different software platform. What I love about Lightcore Cloud is when you have a ton of wells, you can actually export all of them at the same time. So you can click all the different well locations. You want water level from all 20 of these. You hit export, it all comes out on one Excel file, all in columns, so that you can create a hydro graph right on Excel, a lot easier than kind of putting all these pieces together. And again, non-vented, so you have all these different measurements. And I made it through. So I'm going to I haven't been looking at the questions, but I'm going to have Brett jump in here.
Yeah, thank you so much, Andrew, for the presentation. It was great. I do have a couple of questions here. Answered most of them online, but for everybody else, we can run through those real quick. So,
Perfect.
When you use a waterproof shuttle to read the data off a deployed logger in the field, how do you get the data from the shuttle back on the computer?
Yep. Yeah. So that just like the base station, there's a separate USB cable. So because it's waterproof, it's a separate cable. You gotta undo the cap at the top to plug it in. But you plug that in, it's pretty much a memory device storing all that data at that point in time. And you plug that USB cable into it, then into your software, and then right on that HOBOware app, it's going to allow you to kind of offload all those files.
Perfect. Another question or something that you can touch on real quick, Andrew, is what are the parameters of water quality that are being monitored for the MX800 and for your real-time solutions?
Sure. So with our real-time solutions, there's tons of flexibility. We have options that are pretty seamless for dissolved oxygen, ORP, pH, conductivity. But with our real-time solutions, we also have the ability to take in third-party sensors. So there's a number of sensors out there with output that are compatible with our units, like turbidity, PAR, and some of those other ones. Now with our MX800. That is a platform of the future for us. So today we have conductivity and temperature, and we also have conductivity, temperature, and depth, CTD, and then we have dissolved oxygen and temperature as 3 sensor options, and the ability to do up to 2 at once. But the future of that platform is to do more than 2 at once with an adapter, and we're gonna just we're talking about timeline, but hopefully by the end of this year, you'll see a PAR sensor. Turbidity is also on the list that we'd like to come out with. Maybe in the future, you see nitrates and chlorophyll. But one of the things about our equipment is we are a data logging company. So we try to choose sensors that you can leave out there for extended periods of time and collect good data. So that's why we have, DO. We also have a pH and temperature solution as well. So we have a lot outside of the MX800. We also have standalone optical loggers for conductivity, DO, pH, So there's a number of different solutions.
And, thank you, Andrew, for that, for answering those. Also, we have a question here for your conductivity loggers. Can they be also deployed in the slotted PVC housings?
Absolutely. Yeah, so I think one of the pictures actually was the conductivity logger. And I would suggest that for most of our, most water quality loggers, you want to allow flow to the sensor, but you also want to protect it. So whether it's perforated pipe, slotted PVC, maybe you put some sort of copper protective housing around it, which we sell for the MX800. But yeah, you can absolutely put any of the water quality equipment also in there as long as you are getting flow to the sensor. But it should be really, because it should be protected.
Perfect. Another question we have here is, how accurate is the data when you're using constant barometric pressure option? So I'm guessing the question
Sure.
is versus barometric pressure than using a vented option.
Yeah, so the question, I think, pertains to if you're going to use maybe an outside source or just use a constant constant baro reading, essentially, to compensate for an entire data set of our pressure transducers. And so, to my understanding, it can get as bad as a foot off, and that's really one of the things is that happens during these storm events where barometric pressure is changing, for example. And when those storm events roll through, it's usually when you want to know what those water levels are and you want them to be accurate to kind of see that data. So using a constant baro is not ideal, and it can get as bad, in my understanding, about a foot. Could be worse, I guess, in some cases, but baro doesn't change too much.
Sure, thank you. Another question we just had come in right here is, do you have plans for a salinity sensor that will work with the RX 2100 series data loggers?
For the RX20 salinity sensor? Yep. So
Yes.
that I mentioned conductivity as a solution for the real time, and that conductivity will give you a salinity measurement as well.
Yes, that will go through our, to answer that question, that will go through our RX 3000 that we have it available. We don't have it for the RX 2100 series yet.
You could actually do it. We have it with that HOBOnet system. So we have a
Yes.
HOBOnet analog mode, and that would work with the RX 2100 in the wireless platform. But yes, the RX 3000 could be tied directly to that sensor.
Correct. Yeah, so you can do it with a moat, or you can do it with a RX 3000. Okay, let me review here real quick. The different options for software to be able to pull off, and what is the cost between the HoboWare Pro and the Hobo Connect?
So Hobo Connect is a free software. HoboWare Pro is a $75 download. So it's kind of more of a one-time thing. If you're talking Lightcore Cloud, the cloud-based platform, that's really a free software. What you do pay for is the station's SIM card and data storage, essentially. And so that's per station. We have cell plans or data plans as low as $99 per year for the station. And when it comes to those wireless sensor networks, you're actually not paying per wireless sensor. You're paying just for the single station. So the highest plan that we offer is more for those big wireless networks of, like, if you're doing 50 sensors, it's $399 per year. So you can manage 50 wells real time with everything that comes along with the cloud software for $399. It's very inexpensive.
Awesome. Yeah, we're looking at this is probably the last question here. We just ran over time. Thank you everybody for still hanging on here. Just one more. What are the climate parameters that you can monitor with your real-time stations?
Yep. So rainfall's a big one when it comes to water level, but you also have wind speed and direction. You have solar radiation. You have PAR, or photosynthetic active radiation. You have temperature and relative humidity, leaf wetness. What am I missing, Brett? We have soil moisture sensors too. And then if there's other climate parameters, again, we allow for somewhat third-party integration. So there's other options as well beyond what we carry as more of just a plug and play.
Sure. I got one more. We're having a couple more come in, so whoever wants to still hang on, we'll answer a couple more
Sure.
here. We have a customer that's looking to use the HoboNet water level system. They want to know about the connection between the devices on large sites that are heavily forested. What's the
Sure.
range that can be expected?
Yeah, so it really varies. It varies because of the vegetation. And so I'll say this, if you're looking to do that, tune in next Wednesday because I'm going to be talking about HoboNet water level and the start to finish process of that and really kind of dive into it. But ultimately, in a forested environment, you got to worry about a couple things. You have to worry about obviously distance for connection. You also have to worry about, how much canopy is there and is it blocking my solar just because it's solar powered. Usually they do pretty well under canopy, but you want to make sure that, you're conscious of that. And so when it comes to a forested environment, I've seen that it's still, so typically a wire from sensor to sensor, you can get up to 2,000 feet line of sight. And then you can hop up to 5 times. So you can go 2,000 feet, another 2,000 feet off of that, and you can kind of build that network. When it comes to a forested environment, I've seen, and I try to use when I'm building out a system, which you have my contact right here. If you're thinking of doing that, I highly suggest us getting on a call, and we can look at your site, maybe on a KML or on Google Earth, and kind of look at these well points. And I'll design you out a system that I feel comfortable with making a strong HoboNet network. But I've seen in kind of worst case, 300 feet from sensor to sensor, which in some cases is okay, but that's worst case. And one of the things that we offer, is you can bridge the gap with any of those wireless parameters. So rainfall, repeaters, we have low cost repeaters that you can bridge a gap with. So those are all options to kind of, continue to use the network and scale it without having to buy another station.
Perfect. Just one last question here. Will you ever be able to come out with a smart sensor for conductivity and pH rather than hooking up into an analog?
I can't really answer that. I don't know if that's on the roadmap for us, but I'd love to see it as well. So I hope
Yeah,
that we can do all those water quality sensors at some point and tie them into the RX station. But that's not above my pay grade.
for sure, for sure. Yeah, it would be nice, but you know what? The analog solution is pretty seamless. It's just a little bit more wiring instead of plugging in. So we still have a great solution that works. So that's it right now. We're good. We follow up with all the questions. So thank you so much, Andrew. Really appreciate it.
Awesome. Thank you, everyone, for joining. As I mentioned before, this is recorded and will be sent out to everyone. Feel free to reach out to me directly or any one of our staff. Appreciate you jumping on today.
All right, awesome. Thank you so much.